Bismillahirrahmanirrahim. In this video, we will talk about the red black trees. A red black tree is a binary search tree, right? With that contains a key value, right? A pointer to the left child or left subtree, pointer to the right subtree, and pointer to its parent, and one additional bit for color, right? So this color could be either red or black. That's why we call it the red black tree. One thing. Second thing is, it is a balanced, approximately balanced binary search tree, right? The red black tree is an approach to make a binary search tree as a balanced binary search tree with an additional bit of color that is either red or black. So what is the definition of the red black tree? There are some rules. If some tree follows these rules, that tree is called arbitrary or the red black tree. So number one is, every node is either red or black. So every node in a BST is either red or black. There is no other choice, right? Second thing is, the root of the BST is always black. Root is always black. Third rule is, the leaf node, whatever is the leaf, every leaf is black, right? So if a node that does not have any leaf, for example, if there is a node, right, the last node, so in a complete binary search tree, if there is a node, it always contains two children, that is nil, right? If it does not contain any children, any child, it has two children, that is nil. So these nil are always black, right? So the rule number 4 is, if a node is black, if a node is red, then both of its children, both children are black. That means a red node cannot have any red child, right? So if a node is red, then all the children are black. And finally, last property is number 5, is, for each node, all simple paths from node to descendant leaves contain the same number of black nodes. So all paths from root to leaves contains same number of black nodes, So if any tree, binary search tree, follow these properties, these rules, right, so that that binary search tree is called a red black tree. Clear? So we'll see some examples of the red black tree. Let's consider this example and check whether this given tree is a red black tree or not. So what is the definition of the red black tree? We just discussed that number 1, it should be a binary search tree, right? If you remember from the previous slide, you can see first one is it should be the binary search tree, and then every node is either red or black. So this is a binary search tree. We know that 11, the smaller values are on the left hand side and the greater values are on the right hand side. So every node should be either red or black. Yes, every node color is either red or the black. The root is always black. So this is the root value, root color of the root is black. Okay, the leaf nodes are black. So leaf nodes, nil nodes are black. We already know that all the leaf nodes are black. Okay, if the rule number, the fourth point is if a node is red, then both of the children are black. So the red node, both of the children are black. Red node, both children, it doesn't contain actually the children's, but if the nil nodes, nil, the color of the nil node is always black. So the red node, so it doesn't contain uh, any children, but if the children are there, so those are the nil children, and that is the color of the, that is the black. And the finally, all path from root to leaf contains the same number of black nodes. So from the root to the all leaves, this is the leaf, so root to the leaf, number of black nodes are 1 2, right? So another is this leaf, number of black nodes 1 2. So another leaf is this one, number of black 1 2. This is another leaf node, right? Yeah, this is another leaf node, so number of black nodes from 1 2. So root to all the leaves, number of black nodes should be same. So in this case all the number of black nodes are same, so yes, this is a arbitrary red black tree. Okay, now let's see how to construct a red black tree. Since we know the definition of the red black tree, we know how what is the definition. So now let's see how we can create a red black tree. That means how we can insert values, key values in arbitrary, so that the property does not violate, right? So in order to insert any value in the red black tree, first of all, let's understand some rules, right? Since we already know that in the previous video in the AVL trees, whenever the property is violated, we need to perform some rotations. Similarly here we need to perform some rotations, but the cases are different. So let's discuss those cases. So here again we have four cases. Number one is, let's say I want to insert the key, that I want to insert is key Z, right? So if you are inserting the first key, remember, whenever you are going to insert the first new key element, the color of the new key is always red, right? Whenever you are going to insert a new key node in a red black tree, the color of the new node is always red. Okay, so if the node that you are going to insert is the first node, that means the root node. If it is a root node, you have to, what you need is, you just need to recolor it, make the color black. If since it is the new node, the color will be red, but you need to change it to the black, since it is the root node. So rule number one is, if Z is root node, what you need to do is just uh, it will always be black, so just change the color to black, right? That's it. Number two, this case is interesting. Here what you need to check is, when you have inserted a new node, you need to check the uncle of that node. So if Z dot uncle, we will do one example and we'll understand what does it mean. Z dot uncle, if the color of Z dot uncle is red, that means the uncle of the new node, the color of the uncle of the new node is red. Then what do you need to do? You need to do few things. What? Change the color of Z dot parent, change the color of the parent, Z dot uncle, and Z dot grandparent. So if the color of the uncle is red, change the color of its parent, its uncle, and its grandparent. Fine, it's okay. We'll see some example and we'll understand. Number three, rule number three is, if now if the uncle is red, that then it is fine. But if Z dot uncle is black, now then there are two cases actually. Uh, like for example, if you have inserted one node right? For example, you have inserted the node, okay, you have inserted a node here. This is the new node Z. Okay, so the color is red, right? Okay, and what you did is we need to check. So this is the new node. What is the uncle of this Z? Uncle is the parent sibling, right? So Z's parent is this one. Its sibling is the uncle of Z. So if this is black, this uncle is black, and the Z that you are going to insert is in front of this set, this uncle, right? In front of the uncle, meaning that it is making a triangle, right? It's making a triangle with uncle, right? It's making a triangle with uncle is in front of this uncle. So what does it mean? If Z dot uncle is black and Z makes a triangle with uncle, or in other words, in front of uncle, right? So then what you need to do, simply the rule is then rotate, first of all rotate Z dot parent, right, in opposite direction. So just rotates the parent. If in this case, for example, rotate the parent in this direction, so Z will come up and this will go down like this one. Okay, and then rule number 4, finally the fourth rule is okay, so if Z dot uncle is black but Z doesn't make a triangle with its uncle, but it makes a line with its parent. For example, like this is the uncle, this is the parent, and this is Z that is inserted, right? So what does it mean? It means Z is not in front of his uncle, it's not making any triangle with its uncle, but it is in front of, with it, it's making a line with its parent, right? And Z makes a line with parent. Then what you need to do? You need to do two things now. Number, rotate Z dot grandparent in opposite direction, right? Number one, change not the Z dot parent but Z dot grandparent. So this grandparent will be rotated in this direction because Z is here, so this will be rotated in this direction. Second thing, now you need to exchange the color of grandparent and parent. Whatever is the color of parent and grandparent, just exchange it. So these are 4 basic rules and cases in order to insert, in order to create a red black tree or insert the node in a red black tree. So now let's do one example and then we'll see how we can insert the key values in a red black tree. So let's see. Let's say for example, if I have some data elements, data set like 4, 7, 12, 15, 3, 5, 14, 18, 16 and 17. This is the data element and I want to create a red black tree. So remember, this is the binary search tree, right? So it will follow the binary search tree properties. So first of all, what will be done? Remember, so take a note of these rules because we will follow these rules very frequently now. If after every insertion of the every insertion of the node, we will follow these rules in order to insert any node in this red black tree. So what we will do, first of all, we get 4. Since, remember one point again, I am telling you, whenever you are going to insert any new node, the color of the new node is red. So I am going to insert the first node 4. So the first node is 4, so the color will be red, right? So the rule number 1 says, if Z is the root, this is the root node, then what you need to do, you just need to make it black. So this will be transformed to black color. That's it, right? Rule number 1 is done. Now let's insert the new node. Next node is 7. So 7 is greater than 4. It will go in the right of 4. So the new node is red, so it will go in the right of 4, 7. Now we need to again check the definition of the red black tree. What is the definition? Remember the rules, right? So the definition says the every node is either red or black. Yes, it is. The root is always black. Yes, root is black. The leaves are black, so leaf is also black. If you can see why, because it contains the nil nodes. It also contains another left subtree, that is nil. It contains 2 children left and right, that is nil nodes, right? So basically that are not children, but that are black color, so it fulfills the properties. And if a node is red, both of its children are black. Yes, red doesn't have any children, so it's okay. All the paths, so that's fine. All the paths are having the same number of black nodes. The next is 12. So now let me insert 12. So if I insert 12, so 12 will go in the right of 4, in the right of 7. So 12 will go here. Now let's see whether it fulfills the red black tree property or not. So root is black, yes. Leaf is black, nil nodes are black, okay. But the fourth point in the definition is if a node is red, then both of its children are black. But here 7 is red and 12 is its child, that is also red. So this violates the property. This violates the property of the red black tree, right? So what we need to do now, we need to check these cases now, the insertion cases. We inserted 12, now we need to check the cases. So this is the node that we are going to insert, that is Z node, right? That is 12. What is the uncle of 12? Uncle of 12 is nil node, right? That is what? That is of black color. So it says if the rule number 4 is then there. If you make a note of the node, the rules, rule number 4 applies here. This is the Z. Z's uncle is black and Z is making a line with its parent. Okay, then what we need to do? We need to do 2 things. Rotate the grandparent of Z. What is the grandparent of Z? That is 4. Rotate the 4 in opposite direction. If we rotate 4, what will happen? 7 will come here, 12 is here, and 4 will go down, right? Number 1. Number 2, it says exchange the color of grandparent and the parent. So color of grandparent and parent, change the color. So okay, so grandparent's color is red, it will become black, right? And so grandparent was 4, so the color of grandparent was color of parent and grandparent, parent is 7, so 7 will become black, right? And the grandparent is 4, that will become red, and 12 is already red. So now you will see this fulfills the property of the red black tree. Okay, so now let's insert the next key value, that is 15. So let's insert 15 in this tree. So 15 will go in the right of 7, in the right of 12, right? Now again this violates the property. Why? Because a red parent cannot have a red child, right? So this violates the property. Now we need to check the rules. With the rule says check the color of the uncle. The color of the uncle is red, right? That is the rule number 2. Color of the uncle is red. So then what we need to do? Just we need to change the color of parent, uncle and grandparent. So change the color of these three: parent, uncle and grandparent, right? So if we change the color of parent, uncle and grandparent, so the okay, so the grandparent is black, so this will become red, right? The uncle and parent both are red, so they will become uh, black, right? And the new node that is already of red color. Clear? But then this violates the property that the root node should always be red. So if this is the case, what we will do, simply we will, the rule number 1 is applied, change the color of the root. So the root color will be changed, so that will become 7 as a black, 12 in a black color, 4 in a black color, and the new node 15 is the red. Now check the properties. So properties, root is black, okay. Leaf nodes are black, okay. So uh, the all the black nodes from root to descendants are of same number. So this is 2, this is 2, everything is fine. So this is the red black tree. So now let's insert one more element, the next element, that is 3. So if I insert this 3 into this new in this tree, so 3 will go in the left of 7, in the left of 4, so 3 will be inserted here, right? So it still follows the property of the arbitrary, so no problem at all. So the next node that we want to insert is 5. So 5 will go in the left of 7, in the uh, right of 4, right? The right of 4. So 5 will go here. So let's check now the properties. So it still follows the red black tree properties, so no violation, it's fine. So the next key value is 14. So 14, if we insert 14, it will go in the right of 7, in the right of 12, in the left of 15, the left of 15, right? Now this violates the property. Why? Because 15 is red and it cannot have a red child. So in this case we will check the rules now. So this is the Z node 14 that we inserted, right? So we need to check the color of its uncle. Who is the uncle of this 14? Uncle is nil, that is of black color, right? So uncle is black, so and it makes a triangle with its uncle, right? So rule number 3 is following. So the rule number 3 is, what we need to do is rotate the parent in opposite direction, right? So if we rotate the parent in opposite direction, then what happens? So who's the parent? Parent is 15. Rotate the parent in opposite direction means you have to perform the right rotation, right? So what will happen? So 7 is there and at the same place, 4 is at the right place, 12 is at the right place, and these 3 and 5 are fine. 3 and 5 are fine. Now we need to rotate this. So if we rotate this, 14 will come here and 15 will go fine. So it still violates the property, right? Why? Because both are red. 14 is red and have a red child, that is 15. So in this case, now again we need to check the uncle of the 15. Uncle of 15 is nil, still nil, that is black. And now it does not make any triangle with its uncle, it makes a line with its parent. So the rule number 4 will be followed. Rule number 4 says rotate. Now this is Z, right? This is Z, because of this the rule is violated. Now it says, the rule number 4 says rotate the grandparent. Who is the grandparent of 15? That is 12. So rotate the 12 in opposite direction, and also change the color of parent and grandparent. So 7 is fine, 4 is fine, and 4's children, that is 3 and 5, they are fine. This is the problem. 15, rotate the grandparent in opposite direction. So grandparent, if we rotate the grandparent, so 14 will go up. And okay, so this is the, remember, this is the parent, z dot parent, and this is z dot g grandparent. What we need to do, we need to rotate the grandparent in opposite direction and need to change the color of parent and grandparent both. So let me do it directly. If we rotate it, so 14 will go up and the color will be changed. Color of 14 will be black, and 12 will come in the left and the color will be changed. It will go right, become right, and 15 will become, 15 is already red. So that's, now we'll check whether the properties, so you can see the properties, it follows the red black tree properties, right? So all the leaves are black, the root is black, the number of black nodes from root to all the leaves are same. That's fine. Now let's insert the next node, that is 18, right? So if I insert 18, 18 will go in the right of 7, in the right of 14, in the right of 15. So here we insert 18. This again now violates the property of the red black tree. Why? Because red cannot have a red child. So now we need to check the color of uncle. This is z, color of z, uncle of z, that is 12, so that is red. So if it is red, then the rule number 2 will apply. Rule number 2 says what you need to do is just change the color of parent, uncle and grandparent. So this is parent, this is grandparent, and this is uncle. So you need to change the color of these three. That's it. So that means the, let's redraw this tree. 7 is there, 4 is there, that is fine. 4's children are fine, this is fine. And color of grandparent, this one, this will be changed, right? So this will become red, right? Color of uncle or parent, both will be changed, so they will become black. And z will remain same, so z is here, that is 18. So now you can see this follows the properties of the red black tree. So if a node is red, both of its children should be black. So you will check this follows the property of the red black tree. Now let's insert the next key element, that is very quickly, that is 16. So if we insert 16 in this tree, so where the 16 will be placed? In the right of 7, in the right of 14, in the right of 15, but in the left of 18, isn't it? So 16 is greater than 15 and smaller than 18, so it will go here. Now the property is violated again. Why? Because red cannot have a red child. So what should we do? We need to check the color of the uncle of Z. Z is 16. So the color of the uncle is nothing but black. If it is black, then what we need to do? So the case number, okay, it color of the uncle is black and it is also making a triangle with its uncle, right, in front of its uncle. So the case number 3. So the case number 3 says, what case number 3 says, rotates its parent, right, rotate its parent in the opposite direction. So this is the z dot p. So this will be rotated in the opposite direction. If we rotate this, so what will happen? So 7 is in the right position, 4 is fine, 4 children of 4 are fine. Let me draw it quickly. Right, and we need to rotate the parent to the opposite direction. So 16 will come here and this will go in the opposite direction, 18, right? So it still doesn't follow the rule of the red black tree, since both are, the red parent has the red child. Now this is the Z. So note, you must notice one thing: whenever we are following the rule number 3, ultimately it follows the rule number 4. So after following the rule number 3, we have to follow the rule number 4. That rule number 4 is check the parent, the uncle is black, that is nil, and it is making a line with its parent. So it's making a line with its parent. So what we need to do, we need to rotate this is parent, this is grandparent, we need to rotate this grandparent in opposite direction like this, one thing. And also we need to change the color of this parent and the grandparent. So let me just draw it directly. So let me draw it. So what will happen, 7 is, right? So we need to do is rotate the grandparent in the opposite direction and change the color. So that is 15. So 15 will come down, 16 will go up. So 16, if 16 will go up, we need to change the color of 16 as well. So that will become black, right? 16 will become black, and we need to rotate the grandparent. So grandparent will come in this direction and the color will be changed, and Z is in its position, that is 18. That is fine. So now this follows the property of the arbitrary, you can check, right? So all the leaf nodes are black, number of black nodes in from root to all the leaves are same. So 1 2 1 2 1 2, so all are the same. So now let's insert the last value, key value, that is 17. So let's insert 17 in this tree. So if I insert 17, so it will go in the right of 7, right of 14, right of 16, and the left of 18, right? So this violates the property. If this violates the property, what we need to do? The rule number 2, we need to check the color of the uncle. The color of the uncle is red, so it is rule number 2. So rule number 2 says change the color of parent, grandparent, and uncle. That's it. So let's redraw it. So grandparent is 16, that is black, so it will become red. It will become red. Uncle and parent both are red, they will become black. And 17 will remain red. Okay, so that's it. So let's see if it violates the property or not. Now yes, this violates the property. Why? Because again here, so 14 is red and 16 is also red. Both parent and child cannot be red. Now let's see what property, what rule is violated, or what case should we apply. So because the rule is violated because of this, so this will become Z. If this is Z, we need to check the color of the uncle. So the color of the uncle of Z is, color of the Z uncle of Z is 12, so the color is black. If the color is black and it is not making any triangle with its uncle, it is basically making a line with its uncle, right? So what should we do? So what's the rule? So 16 is okay, parent of 16 is 14 and uncle is 12. So who is the uncle of the 16? So actually this 12 is not the uncle of the 16, this 12 is the sibling of the 16. So the uncle of 16 is 4, right? So the uncle is always obviously the sibling of the parent, right? So sibling of the parent is 4. So the color of the uncle is black. Okay, so the color of the uncle is black, and this is not making a triangle with its uncle, it is making a line with its parent. So that is the rule number 4. So it makes a line with its parent. So if the rule number 4 says, what we need to do is, this is Z, rotate the grandparent. So this is the parent, this is grandparent, this is uncle. So rotate the grandparent in opposite direction and change the color of parent and grandparent. So it means this will be rotated in this direction. So let's rotate this and change the color in one go. So the color of the parent and grandparent will be changed, right? So if we rotate the grandparent in opposite direction, so 14 will become root and the color will be changed. So 14 will become root and the color will be changed to black, right? So 7, okay, 7 will go in the left hand side, and 7 is obviously it will rotate it like this. So 7 will become red, because we need to change the color of the parent and the grandparent, right? And then this 4 and rest of the things are fine. So 4 is the child, and 3 and 5 are fine. Okay, now let's see. Okay, so this 14 becomes up. Now this 16, that is the Z node, so this will be here, so that is red. So 16 is here, right? And the children of the 16 are 15 and 18, that is fine. And the new node that we inserted was 17, that is in red, that is fine, right? Now what is remaining is this 12. Remember from the AVL video. So this 12, that was actually the left child of 14. It must go in the left of 14, right? But new left of 14 is 7, right? See, so the 7 is new left child of the 14. So this 12 will be connected with the right side of 7. So here, like this, right? So whatever is the left child of 14 will go in the left subtree of 14, but left child was 7, so this will go in the right of 7, right? So now check if the properties are, if it fulfills the properties of the red, black or not. So yes, the root is black, the leaves are black, all the number of black nodes from root to leaf 1 2 1 2 1 2 1 2, that's perfectly fine. So this is arbitrary, right? So this is how we created the red black tree. Let me just summarize this and recap the lecture. So red black tree, we discussed the definition of the red black tree, what is a red black tree, and then we saw one example of the insertion the key values in a red black tree. So there are 4 rules to insert the key values in the red black tree. Remember, red black trees are binary search trees and the balanced trees. So you can see this is a balanced tree. This is a balanced tree. Why we are going to create this? Because we want to optimize, or we want to get the average case searching time, that is order of log n. Thank you.